Hi there, I'm Dr. Nate Story from Bright Agrotech, and this is Aquaponics Academy episode number 18. Today we're going to talk about phosphorus and some plant micronutrients, except for iron, which has already gotten its own episode.
Welcome to Aquaponics Academy, a Bright Agrotech podcast designed to help you overcome common aquaponic issues, learn new growing techniques, and help you be as successful as you can be as an aquaponic practitioner. Whether you're just getting started or you've been growing aquaponically for decades, this podcast is for anyone wanting to design the best performing system possible. Join aquaponics expert Dr. Nate Story, the creator of Zip Grow Towers, as he breaks down complex topics into easy to understand information. And now, here's Dr. Nate Story.
So, to kick this episode off, we're talking about plant nutrients. And we've been talking about plant nutrients for a while now because they're really, really important to understand. Now, I will throw out the caveat that most of the nutrients that we talk about are not necessarily deficient in many aquaponic systems, right? Typically, our main deficiencies are going to be potassium, magnesium, and iron, right? Those are kind of the big three. But, occasionally other deficiencies will show up. Now, the ones that we're talking about today are not necessarily, they're almost never common, right? With the exception of phosphorus, if you're really growing a lot of nutrient hogs, right? So the first question today that someone asked me was, well, why do you kind of group phosphate or phosphorus with the micronutrients? And the reason for that is that oftentimes, I guess it's just not super necessary in most people's aquaponic systems. I mean, most aquaponic growers are not growing really real big nutrient hogs. They're not growing crops that set fruit. And so phosphorus is just not that deficient in most of these systems. In fact, a lot of the time it's in excess. And so it's really not super important to most aquaponic systems, to the extent that I don't really spend an awful lot of time talking about it. So I'm not grouping it with the micronutrients because I necessarily think of it as a micronutrient. I'm just kind of tossing it in with a lot of these other kind of irrelevant micronutrients. But it's still fun to talk about. And if you've watched the YouTube videos, I did an entire video on phosphorus and supplementing phosphate. In the form of bone meal and, essentially as well as rock phosphate, I guess, and really talking about the role that phosphate can play in systems that have a lot of fruiting crops or crops that set fruit. So let's go ahead and jump into this. So phosphorus is typically available in aquaponic systems as phosphate, right? Well, it's always available as phosphate. Phosphate is the oxidized form of phosphorus that is soluble. It floats around in the solution. The plants take it up and they use it for a lot of different things, but it's really, really mostly important when it comes to setting fruit and fruit development. So if you have fruiting crops, then you want to make sure that you have enough phosphate in your system. Now, I will say that I've very, very seldomly seen any deficiencies in phosphate. It's very, very unusual. And the reasons for that are that there's a lot of phosphate in fish food, and it finds its way into the system, and it's just not always consumed, and so it ends up circulating in the system until plants take it out. And I've very seldomly seen systems where phosphate is the problem. That's not always saying that it's there in enough quantity, but that is saying that other nutrients are much more limiting to productivity than phosphate typically is in aquaponic systems. So don't worry about it too much. And if you have questions about phosphate, go definitely watch the YouTube video I did on the subject. I talk about rock phosphate. I talk about other ways to supplement phosphate that we've used and had really good luck with. And also when it's really, really important to start thinking about supplementing phosphate. Okay, so phosphate is something to think about. Definitely check out some of our other resources on the subject. We're going to move on because we got a lot to get through today. The next nutrient on the list, so phosphate is a major nutrient, right? You've got NPK. Phosphate is the P in between nitrogen and in between potassium. And phosphorus is available in the form of phosphate. It's a major nutrient, and it is very important for plant metabolism. So not to demean it, but moving on, The next is a micronutrient, and that is boron. Okay, so I don't talk about boron very much, but I will say, actually, I did another YouTube video on boron, so check that one out too. It's really important with cell wall integrity, so it helps form cell walls. And so when the plants are expanding and growing very quickly, boron is an important part of that process. Now, when you don't have enough boron in your system, you see death of the meristem, you see growth and fertility issues, and fruit setting, as well as development. So the either fruit won't set or it'll develop really poorly. You see yellowing at the tips of the plant, and sometimes like core rots or rots in the core of the roots or stems, and some dieback in really extreme instances. Boron isn't necessary in very high concentrations, and it is very, very seldomly deficient in aquaponic systems, but it is something to keep an eye on, and it's typically better to have more boron rather than less. So a lot of people will ask me, how often do you supplement boron? And I'll say very rarely, like once a quarter. So once every 2 or 3 months, I'll put a little borax soap in my system. Not much, just a teeny tiny little bit. A little bit goes a long way. So I'll just take a little scoop of borax, or if you want to do it more regularly, a couple pinches, and add borax soap to your system. It's a cheap and easy way to supplement boron. Don't add too much though. Your fish won't like if you dump the entire box in, but you shouldn't need that much. Just a little bit will go a really long ways. So it's not a common deficiency. It's not something you really need to worry about. But if you are having growth and development issues, boron can be part of the problem. There's probably other things that work there as well, but it's definitely good to know about. Go online, definitely get a key, and go ahead and key out your deficiencies. And I would be surprised if one of your deficiencies ended up being boron, but I wouldn't rule it out. The next micronutrient is copper. This is, again, very seldomly deficient in aquaponic systems. And the reason for that is just copper finds its way into the system. It's a common component in fish feed. There's usually a lot of copper in fish feed. And of course, there's always copper in different components that find their way into our systems, whether we like it or not. Right. So, it's really important for cell wall development, again, and copper is part of a lot of catalysts. So enzymes inside of the plants, they do all of this work. We're talking, they catalyze reactions, and then these proteins and enzymes that help the cells do what they do. Copper plays a major role in a lot of those reactions. So copper is an important plant nutrient. Definitely can be a very important plant nutrient. It's most available at low pH too. So as you get higher and higher pH values, you're more and more likely to see a copper deficiency. Again, it's very, very rare in aquaponic systems, but it's worth keeping in mind. And usually copper deficiencies manifest as like tissue chlorosis, or as it gets going, more necrosis. Now it's immobile in the plant, and so what you typically see with copper deficiency is that the young growth is most affected, right? So the older growth, it has enough copper, but as the deficiency sets in, or as when there's not enough copper to go around, it's the younger leaves, the younger tissues that end up kind of, showing the deficiency. And it can impact flower set. So a lot of times you won't even get your fruiting crops to flower. But it can do a lot of different things. And dieback of the tips, the apical meristem, the tip of the plant will die back, and this causes plants to branch out a lot, or in grasses, what they call tillering, where the hormones aren't being produced by the apical meristem, and you just end up with a lot of brand new branches lower down that get started. Or shoots. So this isn't necessarily a good thing, and it's pretty indicative of a copper deficiency. So you can keep your eye out for those types of things. Again, I'll be very surprised if you experience a copper deficiency. You almost never need to supplement copper, but if you do, of course, there are copper is pretty soluble, especially at low pH values. And a lot of people use things like copper sulfate as a fungicide. And of course, it finds its way into the system. Now, again, I would really not recommend you substitute copper because if you remember, copper is super toxic to fish. Fish do not like copper. And so you have to be really, really careful with it if you are supplementing it in any way, shape, or form to make sure that you're not going to kill your fish by supplementing it. So the next nutrient is chloride. All right, chloride is common in feed. I mean, we use calcium chloride, potassium chloride, magnesium chloride. These are all really common constituents of feed products, as well as other things. I mean, if you remember, we supplement magnesium, calcium, potassium quite regularly with chlorides. Well, the plant's absorbing those chlorides as well. It's not just the magnesium that the plant is taking up, it's taking up all of it. Right. So chloride is a really important thing for osmotic regulation. So when the plant is moving water around the plant, it pumps chloride ions across membranes to kind of help the water move through the plant. And where it's most common is in like stomatal regulation, so opening and closing the stomates, getting those cells big and fat so they open up, and then pumping water out of them so that they collapse and close. So this is basically, how why chloride is kind of important. Chloride and potassium. I guess potassium ions are really, really common for these purposes as well. But it also kind of helps with regulating some enzymes, and it is very rarely deficient in these systems. I would be really surprised if you have a chloride deficiency because you're introducing it in a lot of different ways. But if you do see like distinct white spots along their leaf fringes and they kind of expand, it can indicate a chloride deficiency. Now, I think you've got a better chance at winning the lottery, honestly, than having a chloride deficiency. But I guess it's not impossible. I think it's just really rare. Maybe if you do a ton of water changes and you're not really feeding your fish very much. I guess if you do a lot of water changes and you've got really pure water, there's potential for something like that. But I would. And if you have a chloride deficiency, call me up because I want to hear about it. And we'll have a lab verify it, and I don't know, we'll send you a free tower or something because I'd be really, really impressed. So yeah, very rarely deficient. And at this point, you're probably saying, Nate, why are you going through all these nutrients if we're never going to see deficiencies? Well, let's just treat it as a curiosity of sorts. Because even though it's probably not going to be deficient in your system, it's still kind of fun to think about and know about. And it can or may be useful information at some point. Or maybe you've got a soil garden and you start seeing some of these deficiency symptoms there. Who knows? So the next nutrient is manganese, okay? And with manganese, you get really vivid intervenal chlorosis. And like we're talking white, really bleached out. And, it's really rare. Again, the plant doesn't need an awful lot of it, right? So you kind of start seeing this really vivid intervenal chlorosis. And honestly, it mostly happens when there's like anaerobic conditions or, if your system isn't well aerated, if there isn't enough oxygen, you can end up with some manganese deficiencies potentially. I could see it happening. Now it's really important because it's part of the whole. It's really a key element in photosynthesis, right? And it helps with photosynthesis and carbon fixation. It helps the plant create chlorophyll and some of the carotenoids. And if you have been in Upstart University and you've attended the lighting course there, I talk quite a bit about chlorophyll and carotenoids and what they do. So, manganese is pretty important. And the last thing that it does is it helps with nitrate uptake. So not having enough manganese can actually impact the ability of the plant to take up nitrate, right? And it's possible that those symptoms, that lack of manganese can impact nitrate to the extent that maybe you start to see a little bit of a nitrogen deficiency there. So another thing to keep in mind, it's not necessarily super common in aquaponic systems, but manganese binds with organic matter really well. And so in soil systems, that's a big deal. And in aquaponic systems, not so much. In aquaponic systems, it's more important to know that it kind of has a little bit of an antagonistic relationship with iron, right? So iron doesn't get along very nicely with a few different elements, and manganese is one of them, right? So if you're adding, let me back up. In soil systems, some people will add like a chelated manganese, right? And what ends up happening is that those chelating agents, they're preferential towards iron. So they'll actually, if they contact the iron, they basically will chelate the iron instead of the manganese, and the manganese will precipitate out, and the plant will take up the iron, right? So it's kind of a weird relationship there, but they don't get along very nicely. So an excess of iron can actually impact manganese uptake and vice versa. Now, I've never seen that really happen in an aquaponic system that I'm aware of. It might be happening, and I'm just not really nailing it down very well. But, it's something to keep in mind. And you're going to start seeing those deficiency symptoms in the young tissue first. So as far as supplementing manganese, I've never done it, honestly, in an aquaponic system, but there are commercial manganese type products out there that you can use for soils and gardens. And you might just try using those and starting at very low levels. Check the labels, make sure there isn't anything nasty in there. And if you have any questions about it, feel free to just let us know, and we'll go through that label with you and make sure it's all safe. So that's enough about manganese. The next one's molybdenum. And molybdenum is a really interesting nutrient because it becomes unavailable. It's one of the very few, right? But it becomes unavailable at low pH. Everything else becomes more and more soluble at kind of lower pH values. But molybdenum is not, right? Molybdenum is a weirdo. And it is more soluble at higher pH values and less soluble at low pH values. And that is actually kind of cool. So the interesting thing about molybdenum is it actually presents as a nitrogen deficiency or a nitrogen toxicity. And that's really, really weird because it's basically faking you out, right? So what you'll see is a nitrogen deficiency, and you'll think, oh, I don't have enough nitrogen. And then you'll test your water and you'll be like, well, I got a lot of nitrogen. What the heck is going on? And the reality is that molybdenum is like one of the most important parts of a enzyme called nitrate reductase, right? So we've got nitrate. It's a nitrogen atom connected to 3 oxygen atoms, and the plant needs to reduce that. That means strip those oxygen from that nitrogen in order to do anything with that nitrogen. So the plant has to strip those things away, and it needs to reduce nitrate. And in order to do that, it uses this enzyme called nitrate reductase. And if there's not enough molybdenum in the plant, it can't create that enzyme in enough, at least enough of it. And so what you end up with is initially basically like a nitrate or a nitrogen deficiency, right? The leaves will be pale and small and chlorotic, not interveinal chlorosis, but actually chlorosis of the entire leaf. And then interestingly enough, as the plant takes up more and more nitrate, it starts to accumulate, and you start to see a nitrogen toxicity symptoms, right? It turns necrotic. You start to see these interveinal necrotic spots start to form. It's really, really weird. And that comes back to molybdenum. Now, to be fair, you don't need an awful lot of molybdenum. And I've actually read that for some crops, there's enough molybdenum in the seed. If the mother plant was healthy, then the seeds that are produced oftentimes have enough molybdenum to, at least create semi-healthy offspring. without, even in a molybdenum deficient environment. So it doesn't need an awful lot of it, but it's just kind of cool, and it's kind of a fun idea that sometimes, in some systems, not necessarily aquaponic systems, but when you see that nitrogen deficiency, what you're really seeing maybe is molybdenum deficiency, or nitrogen toxicity. You may just be seeing molybdenum deficiency. It's kind of a neat idea. Okay, so last one here, guys, is going to be zinc. All right, and zinc and copper do not play nice. I think I forgot to mention this on copper, but zinc and copper do not get along. Right, they're competitive. There's kind of what we'd call an antagonistic relationship between them in the root zone in the growing plant root environment. Right, so it's when you see a zinc deficiency, it'll be like stunting. The growth gets stunted. There's these white, sometimes there's these weird white bands that kind of run along the midrib. They're not necessarily always along the fringe of the leaf, but they actually run kind of up down the middle of the leaf along the midrib. It's kind of weird. And a lot of the time you'll see kind of the upper foliage be kind of yellow and the bottom foliage will be kind of bronze. Almost bronzing or brown, almost like you'd see with, say, a magnesium deficiency. But it's useful for a lot of different things, including a lot of different cellular reactions inside the plant, cellular metabolism. So you have to have zinc. Now, another thing that can impact zinc is phosphate, right? So if you got too much phosphate in your system, if it's really sudsy, if you're adding a lot of phosphate, and if you kind of get if you have a lot of bubbles that kind of form on the surface and don't go away, it almost looks like soap bubbles. A lot of the time that indicates excess phosphate in your system, and that's not necessarily good. And that can actually impact zinc. So too much phosphate can basically induce a deficiency of zinc. So that's one thing to keep in mind as it relates to phosphate and zinc. So again, I've never really seen a serious zinc deficiency in aquaponic systems, and I think the reason for that is galvanized steel. And I think the reason is that, most people use enough like galvanized steel washers, nuts, bolts, that kind of thing, that things are falling into the solution, they're falling into the tanks, and, you have zinc entering the system. Now, zinc is ionic, right? So it just will dissolve right into that acidic water, and plants will take it up right out of that water. So, it's also toxic to fish like copper. So, zinc and copper behave really similarly in some ways, and that's one of the reasons why, if there's too much copper, you can see a zinc deficiency. If there's too much zinc, you can see a copper deficiency. They need to be kind of balanced, and because they behave similarly in some ways, they're both pretty toxic to fish. So if you have, galvanized steel, you've heard me talk about galvanized steel and how bad it is. If you put a bunch of fish in a galvanized steel tank, they're probably going to die, right? Because that zinc is pretty darn toxic to them. Same thing with copper parts and pieces. You want to keep zinc and you want to keep copper out of your system as much as possible. So kind of some fun stuff with zinc. Keep it out of your system. If a galvanized steel washer or something falls in there every now and then, or a zinc plated washer, it is what it is. It's not going to kill everything, but you don't want to go off and use a galvanized steel stock tank. That's not going to work out so great for you. So that's about all you need to know about zinc, and that pretty much wraps up all of the plant nutrients. I think at this point in these podcasts, I've talked about just about every plant nutrient that there is. And I think I'm going to have to go back and double check all of my notes now so I don't look like a complete idiot. But my guess is that I've talked about almost everything, even the ones that you're probably never going to see deficiencies from. But it's just kind of fun stuff, and it's really neat how the plants use these things. And so it's always kind of fun to talk about how they interact with each other and what they can do to plants and for plants. So that's it for this episode. Thanks so much for tuning in, and we really hope that you're finding these podcasts useful and helpful. And definitely keep tuning in. We're going to continue to dive into some of the nitty-gritty details of aquaponics. Hopefully it helps you become a better grower, helps you to develop healthier systems, and helps just make you a lot happier with how things are going. So on behalf of everyone here at Bright Agrotech, we hope you're going to stay tuned for more useful aquaponics tips and techniques in future episodes. Thanks so much.